Welcome to the lesson on 15.2, graphing logarithmic functions. So how's the graph of g of x equal to 8 times the log of base b of x minus h plus k, where b is greater than 0 but b is not equal to 1, related to the graph of f of x is equal to log base b. That a should not be here. That's a typo. Sorry about that. So we're going to start with log base 2 of x. As you remember, log base 2 of x is an inverse of the exponential function of 2 to the power of x. So the input and the output has been swapped. So the output here is in fact the exponent, and the input is the number that gives number that is resulted when you were to input -1 to the base of 2. So I've already done that out for you right here. So what that means is that typically that would have been the input, but that's the output right now. So 2 to the 0 is equal to 1, 2 to the first, 2, 2 squared is 4, and 2 to the third is 8. So basically what that means is that when you plug in 8, so log of base 2 of 8 is equal to 3, meaning 2 to the third is 8. All right. So until we get really comfortable, we need to refer back to the exponential form. And if you look at this right here, guys, it may make more sense. So the b is equal to 2, and every term over here is written backwards, right? From exponential curve. So if it's 0 is the output, then input is b to the 0. Right? If the input is b to the first, then output is 1. What's the power, right, of the same base? What's the power of the b squared? It's 2. What's the power of b? 3? Well, that's 3. What's b to the -1? Well, the power is -1, right? So the output is the power, the input is the number, right, that you get of the base 2 here, guys. Okay? All right, let's continue on. So what I want you to do is take a little bit of time. Sorry that I didn't have a little sign here for you guys. Why don't you fill this up? Okay, so if you did it out, you've gotten the following. So not every point here will fit into this graph, so just graph what you can and connect it nicely, and then please use your TI calculator to compare and to see how close it is. How about this one? Ln of x. That's a log base e. Do you remember that? Good. Take a little time, pause the video, and you try. Okay. When you did it, you should have gotten these values over here. So that's e to the first, e to the second, e to the third. And you could use a calculator to fill that in. And we'll check to see if you did this correctly in class. But it's something that you should do before you come to class, okay? But I will actually draw it out in class. So let's talk about, for one of them, log base 2 of x, the domain and range, and all the typical stuff that we've been doing in the past, actually throughout the entire textbook, right? So you could visually see that the x is greater than 0. It can never be negative, right? Why is that? Because 2 to the any power has to be positive. Can't be negative. Can't be 0. There's no power. 2 to the nothing would yield you a number that's equal to 0 or less than 0, right? And you could visually see from the graph that y is all real numbers, and then as x goes towards the 0, the y goes to -infinity, and x goes to the right, the y goes to positive infinity. And the vertical and horizontal asymptote, you could visually see that x is equal to 0 here. It's just hugging that wall right there, right? Good. But there's no horizontal asymptote because y is all real numbers. Okay? And the interval where the function is increasing or decreasing, if you're saying, Mr. Yim, you made a mistake, you're absolutely right. I wrote it wrong. I just caught it when I was started recording. So you gotta cross that off, guys. That's actually 0 because x cannot be negative, or nor can it be even 0. So it has to be greater than 0 to infinity. It's always increasing. Okay, it does not decrease. And x-intercept is 1. By the way, x and y-intercept is a value. It's not a coordinate, so it has to be 1. And y-intercept, it doesn't even touch the y-intercept, right? So there's none. So where is the interval positive? Well, when x is greater than 1, the y value is positive. When x is less than 1, right here, guys, it is less than 0. So if you like, why don't you go ahead and try to fill this out, and we'll check it over in class, okay? But the technique that we'll be using is we'll be using 2 reference points, just like we did with exponential form. The first one was 1, 0, and then b, comma 1, and asymptote was 0. When you apply the transformation of vertical transformation stretch or compression by A, or even reflection here, and we got h and k. Those are horizontal and vertical shifts, right? So we have vertical asymptote of x equal to h, and when you go through the calculation, we end up with 1 plus h plus k, and b plus h and a plus k for the second one, okay? And we'll talk about more carefully why that might be the case, but actually, we could talk about it right now, actually. Basically, we're shifting this, right? So whatever we're doing, we are just adding h to the x and k to the y. So that's why we have, this is 1 plus h, this is 0 plus h, k. This one, though, is that every time you move value of b, it becomes 1, right? But that's 1 times a, so that's a. But then again, because of the shift, we have to add h and k. But we'll talk more carefully in class. Okay, so let's try one question with this. So example, state the transformation of the parent graph f of x equal to log 2 of x that produce the graph of g of x, find at least 2 points, and state the domain and range. Well, first thing is that this translates right by 1 and up by 2 because hk is 1, 2. We could clearly see that the base is 2. And there's no number in the front, so there's no vertical stretch or vertical reflection. And using the formulas that we had, x equal to k, which is 2, and 1 plus h is 2, and k is 2, and the equation is b plus h, which gives you 3, and a plus k, which gives you 3 as well. And I just, in red, I just wrote out the h and k to give you a new point of reference, and I went ahead and did 2, 2, and 3, 3. And I just decided to go back and just do a couple more points. If you look carefully, if I move by 1 over here, that's a b squared, sorry, b to the first, which is b is 2, so 2 to the first. And this one, what value will give you half if the exponent was -1? What if it was -2? Like if you go down twice, 2 to the -2 is what? 1/4. The distance from here to here is not 1/4. Okay, and what I want you to do is graph this on your graphing calculator and see if it looks right, and go ahead and connect these points. Okay, guys, that's it for tonight. We'll do the rest in class. Have a good night.